All right, so as promised, we're back with part two, where we're actually going to apply some of the properties of proportions to solve equations. In this case, I'm really going to focus mostly on the cross product property. So if we look, when solving a proportion, we can cross multiply. All the other properties that we talked about in the previous video are useful in certain scenarios, but the cross product property tends to be the one that we use the most when we're solving equations. So let's go ahead and try and apply that property right now. So again, what we can do here is we can multiply the extremes and also the means together and set those equal to each other. So let's go ahead and do that. So 4 times 3x minus 4 equals 8 times 2x plus 1. All right, so we have a couple different options here. One, we can distribute the 4 through the set of parentheses and the 8 through the second set of parentheses. Or the other option is we can divide both sides by 4 at this point, which is what I'm going to do. And that's going to give us 4 divided by 4. That divides out to become 1, and that leaves us with 3x minus 4 on the left-hand side. On the right-hand side, we're still going to have a coefficient out in front of that set of parentheses. That's going to give us 2 times the quantity 2x plus 1. All right, so the left-hand side, we really can't simplify any further. However, just grab some different markers over here. On the right-hand side, we can simplify that. So we're going to distribute, and we're going to get 3x minus 4 equals 4x plus 2. So now, again, it's just a matter of working out the equation here. So I'm going to subtract 3x from both sides. I'm also going to subtract 2 from both sides at this point. 3x minus 3x is 0. Negative 4 minus 2 is negative 6. 4x minus 3x is x. So x equals negative 6. Now, when we plug negative 6 back into the original equation, what we're going to end up with is, and I did this earlier, 4 over negative 11 equals 8 over negative 22. And what we see is that the ratio on the left-hand side is equal to the ratio on the right-hand side. If we were to divide 8 and negative 22 by 2, divide 8 by 2, we get 4. Negative 22 by 2, we get negative 11. So these fractions are equal, which means that x equals negative 6 is a solution to, or is the solution to this equation. Let's take a look at a second example. All right, here it looks like we're gonna have to deal with some quadratics. No big deal. So again, I'm going to apply the same property, the cross product property here. So 5 times x squared would be 5x squared plus 25x. So again, I distributed. And then 4x plus 4 times 9. 9 times 4x is 36x. 9 times 4 is 36. All right, so typically with quadratic equations, what we like to do is to get the quadratic, linear, and constant terms on the left-hand side of the equation, set that equal to 0, and either try and factor or try to use the quadratic formula to find the solutions. So let's go ahead and move everything over to the left-hand side of the equation. So I'm going to subtract 36x from both sides. And we'll also subtract 36 from both sides as well. So on the left-hand side, we're going to be left with 5x squared. 25x minus 36x is minus 11x. We didn't have a constant term on the left-hand side, so that's going to give us negative 36, and that's equal to 0. So 5x squared minus 11x minus 36 might factor nicely. What I'm going to choose to do here, though, is to apply the quadratic formula instead of trying to factor this. Like I said, I think it will factor pretty nicely, but again, we'll just use the quadratic formula to try and save some time here. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's go ahead and work this out. So remember, a, b, and c represent coefficients of our variables when the left-hand side is written in standard form. This coefficient is equal to a, this is equal to b, and then negative 36 is equal to c. So we're going to plug those values into the formula. and evaluate it to get our solution. So x is going to equal negative b, so negative 11 or minus 11 is positive 11, plus or minus the square root of b squared, so negative 11 squared is 121, minus 4 times a, which is 5, times c, which is negative 36. And that's all going to be over 2 times 5. All right, because a is equal to 5. So again, now it's just a matter of reducing this to get our solution. So let's deal with the expression that's underneath the radical sign first. 121, we're not going to reduce that yet. But we have negative 4 times 5, which is negative 20. And then negative 20 times negative 36 is positive 720. So right now we have x equals 11 plus or minus the square root of 121 plus 720. And then that's all going to be over 10. 121 plus 720 is 841. So x is going to equal 11 plus or minus the square root of 841 all over 10. I know 841 looks a little intimidating, but that's actually a perfect square. It's equal to, the square root of 841 is equal to 29. So the solutions to this equation are going to be x equals 11 plus 29 over 10, or 11 minus 29 over 10. So 11 plus 29 is 40 divided by 10. That gives us 4. So one of our possible solutions here is x equals 4. This equation, we have x equals 11 minus 29. So 11 minus 29 is negative 18. Negative 18 divided by 10 is negative 1.8. So the solutions to this one, I'm going to write them up here because I know this is getting messy and I'm running out of space. X equals 4 or x equals negative 1.8. All right, so what I'm going to do is erase all this mess, and then I'm going to come back and we are going to solve example number 3, and that'll be it for this video. All right, so we're back with example number 3, and we are going to solve this system of equations. And this looks a little bit different than what you're accustomed to, again, because we have 2 proportions here, and typically we just have 2 linear equations when we have a system of equations to solve. So let's go ahead and try and tackle this. So my idea here would be, again, use the cross product property, see if we can maybe reduce these down into 2 more manageable equations. So let's go ahead and do that. So we're going to do 2 times x minus 3, so that's 2x minus 6. So 2 times x is 2x, 2 times negative 3 is negative 6. And that's going to equal 4 times y, which is 4y, and then 4 times 2, which is positive 8. Now, again, what I'd like to do here, I see that this is a linear equation. So what I'm going to do is I'm going to manipulate this and get this equation written in standard form. So what I first notice is that all of these terms are divisible by 2. So I'm going to divide both sides of the equation by 2 first. And that's going to give us x minus 3 equals 2y plus 4. And then, like I said, I'm going to manipulate this equation and get it into standard form. So I'm going to subtract 2y from both sides and add 3 to both sides. So that's going to be x minus 2y equals positive 7. All right, so that, again, looks a lot more manageable than what we started off with. Let's do the same thing with the second one. So again, it looks pretty rough right now, but again, I think we can manipulate this and make it much better. So again, we'll start by cross multiplying. So 5 times x is 5x, 5 times y is 5y, and then 5 times negative 1 is negative 5. And that's going to equal 6 times x, which is 6x, 6 times negative y, negative 6y, and then 6 times 1 is positive 6. So it's starting to get better, but like I said, now we're just going to try to manipulate it to get it into standard form. No common factors to divide out. So what I'm going to do to try to keep, actually, you know what? I'm going to subtract 6x from both sides. I'm going to add 6y to both sides. And what that's going to do is that's going to bring all of my terms that contain x and y to the left-hand side of the equation. And now what I want to do is get all the constants on the other side, so we're going to add 5 to both sides. So when we do this, 5x minus 6x is negative x. 5y plus 6y is positive 11y. Negative 5 plus 5 is 0. 6x minus 6x is also 0. Negative 6y plus 6y is 0. And then 6 plus 5 is 11. So again, we're going to go line this up over here. So negative x plus 11y equals 11. So now what we've done is we've transformed, two pretty rough looking proportions into something that looks a lot more familiar to us. All right, so now we're just going to do, I'm going to use elimination to solve this just because everything's written out in standard form. We lucked out here because the coefficients of x are the same number but with opposite signs, so we can just add these equations together. So we'll add those. X plus negative x is 0. Negative 2y plus 11y is 9y. And then 7 plus 11 on the right-hand side is 18. So we'll divide both sides by 9, and we'll get y equals 2. All right, so this is great. We have the value for y. Now we need to find the corresponding x value. So I'm going to select probably just the top equation here to use. So x minus 2 times 2 equals 7. And all I did is I replaced y with positive 2. So again, now we have a pretty nice equation to solve for x. It's going to be x minus 4 equals 7. We'll add 4 to both sides and we'll get x equals, it looks like 11. So 11 and 2 look like our solutions. Let me double check. That is correct. All right, so as I had mentioned before, the cross product property isn't the only property that's going to be helpful when solving equations, but it really is the one that you tend to fall back on the most. Again, in some of these equations, we could have used some of the properties to manipulate the equations initially and maybe reduce some of the fractions down a little bit. But again, the time that you save to do that sometimes maybe isn't worthwhile. Again, I hope this video was really helpful. You're going to go and try some practice problems on your own. We'll see you in the next video.